Dear ladies and gentlemen, welcome to our AIP 2020 talk, which has to do with comparative analysis of inductive density clustering algorithms, MinShift and DBScan. My name is Hu Tyshchenko. I represent the University of Ostrava, Czech Republic. And so today I will talk about a comparison analysis of two inductive clustering algorithms. So first of all, I will give like a brief introduction into the topic. I will tell you about the motivation of our research. I will describe the offered method, and like in the final part of our talk, I will discuss the practical solutions and the practical outcomes we have obtained. So generally speaking, there is a wide variety of clustering methods. So as you know, it's like a principal process for distinguishing semi-empirical patterns from process data. It's like an unsupervised learning technique, which implies dividing a collection of data points into subsets so that elements of one subset diverge to a large extent from the items of all other subsets according to some specific criterion. But when we talk about inductive methods, we imply that there is a combination of classical clustering techniques with the GMDH, the group method of data handling. So there are three actually basic postulates, paradigms that GMDH implies. They are described in this slide, so you can take a look at them. So what we offer in this research is the inductive MinShift algorithm, which was offered for the first time ever. We would like to present some comparison results between the inductive DBScan, which was developed by the same group of authors before, and we would like to determine the maximum density of probability within the objective inductive clustering methodology within the frame of the inductive MinShift. We would like to generally compare two methods in order to find out which technique works better for our specific tasks. So MinShift is just a non-parametric technique for the feature space analysis for determination of the maximal probability density location. So as we know, the MinShift strategy basically assigns data points to clusters iteratively by shifting points towards the highest density of data points, which are cluster centroids. Basically, like I will not leave lots of attention to the classical MinShift. I will put our attention to the offered inductive MinShift scheme. So in this slide, you can see like a general scheme of the offered algorithm. And so first of all, the data comes to the system in the form of a matrix, which is later divided into two equivalently influential subsets. And later we keep on working with these two subsets. We should also select an initial bandwidth P and a change pitch H. So we will keep on working with these parameters in order to improve the performance of our algorithm. Generally, we also estimate the clustering quality of the introduced scheme by means of three quality criteria as the silhouette index, the Dunn index, and the Zelinsky-Kharavach index. We also fix a number of clusters for every subset. I forgot to mention that before. And the general performance of the clustering quality is performed by means of the external criterion, which is like the balance criterion for our case, which you can see in step 8. Then we provide some update of our parameters. We rescale our bandwidth value and the general processing procedure goes until the maximum value of the external criterion is reached. Then we fix a number of clusters and we stop the general processing mode of the algorithm. Our second algorithm under comparison is dbScan. It's a quite popular method. It's like a density-based algorithm that represents the dense concentration points. A similarity matrix is used in this case. So at this point, we define some neighborhood, and all the points that get inside of this neighborhood are considered to be the points of the same cluster. Some of these core points is later picked up as the centroid of that cluster, and we keep on working with these neighborhood distances in order to obtain new clusters. So obviously, I will not dwell on the standard dbScan scheme. So in this slide, you can see the scheme of the inductive dbScan, which is quite similar to, in some basic moments, to the inductive mean shift scheme. Except of, as you can see, like the step 5 is different. So we select different values and we set up different parameters required for the algorithm's functioning, but the rest of the steps are quite similar. So now we come to the most interesting part of our research, like the comparative analysis. So as I have already mentioned, we use some external criterion to estimate the clustering quality of the obtained results. So in our research, we use two data sets, the Jane data set and the Flame data set, taken from the archive from some Finnish data storage, and a link is available somewhere in the slides. So generally, what this external criterion tells us is like an optimal number of clusters and the maximum value of this criterion. So we could come to a conclusion how many clusters are optimal for our case, and like we can see at what level we get the best clustering quality. So here we can see like on the left hand side you can see the results of the inductive mean shift, and on the right hand side you can see like the inductive dbScan. As you can see, both algorithms have detected like two clusters at the data set, but dbScan has performed this in a slightly better way this time. So you can see two distinct groups of points separated, located in a separate way. So I would say that for the Jane data set, the inductive dbScan has demonstrated like the better result. Just unlike the Flame data set, because as you can see here, the inductive mean shift algorithm has showed the better result, because you can see like two distinct clusters nicely separated, but unlike the dbScan, which has produced some strange result in my opinion. We also use the silhouette index in order to estimate a number of clusters and the clustering quality. So actually, based on these presented pictures, you can see that both algorithms detected two clusters in the data set. But in my opinion, so they're quite similar. So one class is dominating over the second one. Generally, there is no difference in this case. But for the Flame data set, you can see that actually the dbScan has detected three clusters in the data set, but we know for sure that the data set contains just two classes, so it's a mistake. And as we can see, the inductive mean shift performed better in this case. So in this slide, you can see a table containing all the parameters and all the tunable parameters required for the algorithm's workflow. So, and summarizing the results of our work, I should dwell on the fact that the inductive mean shift was offered for the first time. It's like some new strategy. It's like a combination of classical clustering plus the GMDH strategy. The balance criterion was used as an external clustering measure. Uh, and I should also admit that the mean shift inductive algorithm distinguishes objects with nonlinear patterns more precisely, while the inductive DB-scan tool is less perceptive to nonlinear objects. But on the other hand, I should admit that both algorithms have demonstrated quite a similar outcome, I would say. So thank you for your attention. It's the end of this talk, so thank you for your attention.